We will look in another lesson at the topic of errors, but for now, we should note that there are two types of error associated with motor programs, sometimes collectively called routine errors. These are action slips and habituation. Action slips usually occur at the selection stage. For example, the throttle, the black levers, may be closed, when what was needed was to lean the fuel supply, the red levers. Habituation, or environmental capture, occurs when an action is frequently made in the same environment. In response to the captain calling for gear down, the co-pilot may say 3 greens without actually lowering the gear. The only way to avoid these errors is for pilots to constantly monitor their own and their colleagues' actions and carry out checklists properly. The information processing procedure will be influenced by many factors, such as a trade-off between speed and accuracy. For example, a delay in making a decision after an engine failure on takeoff could be critical, and there will be pressure to take action, even before all available information has been processed. High levels of arousal will lead to faster but less accurate responses. An increase in age tends to lead to responses that are slower but more accurate. Auditory warnings are more likely to attract attention because they will always be heard, compared to visual stimuli, which may be in peripheral view only. However, auditory warnings are more likely to produce an incorrect response. Prepared responses to emergency situations are an integral part of flight safety training. But if the stimulus is unexpected, the pilot may choose the prepared response instead of a more calculated response. This is called an error of commission. For example, a pilot may have noticed engine instrumentation irregularities, and he has mentally prepared himself to close down a particular engine. An unrelated noise, such as a dropped food tray, may be sufficient to cause the pilot to shut down the engine. The time interval between the onset of a given signal and the production of a response to that signal is called the response time. In the simplest case, such as pushing a button when a light illuminates, the reaction time is about 0.2 of a second. In an actual incident at Manchester, an engine was shut down in less than a second following a bang heard before V1, which is the decision speed to take off. In this case, the correct decision was made. In another case, an emergency occurred after V1, and, as training has instinctively drilled the pilot to continue the takeoff and get the aircraft airborne, the pilot should have done so. But in this case, the pilot thought about the problem, identified it as the elevator, which would have made it actually impossible for the aircraft to fly, and as a result the pilot elected to stop the aircraft. The delay in the response in this case actually was the correct response and prevented multiple fatalities. Response times are relevant, but of paramount importance is making the correct response rather than a fast response. Take your time and do the task correctly, rather than have to start the task again or even make an incorrect response. We have seen that we can acquire skills or motor programs by learning and repetition, and we need to look briefly at the different types of learning. Classic or operant conditioning refers to the behaviorist approach of Pavlov, where the recipient is taught through physiological responses. Pavlov noticed that dogs in a laboratory salivated when they saw a white lab coat being worn, as they associated this with mealtime. An experienced pilot will similarly have an almost automatic response to a stall warning sound, but rather than salivating, the pilot will carry out the standard stall recovery. Insight refers to data that is intellectually or cognitively understood and retained. For example, the way that a pilot sets up the onboard navigation equipment. Observational learning or imitation is very common and would include a student pilot following through as the instructor takes off and then taking off on his own afterwards. Experience refers to learning by our own mistakes. Even though older people may have slower response times, it has been found that their overall performance deteriorates little because of their experience. The quality of any type of learning depends on various factors, such as the intellectual capacity of the recipient, the quality of the communication between the transmitter and the recipient, and the applicability of the data. The place where the information was learned is also relevant. It has been shown that it is easier to recall information when one is in an environment similar to that where the information was learned. Indeed, one research study shows that divers, who were asked to learn words underwater, recalled them better when underwater than on land. Consequently, procedures learned in a simulator will be recalled far better in a cockpit than if they were learned in a classroom. The motivation of the transmitter and the recipient is also relevant, as is overlearning. If one learns a subject in greater detail than is required, not only is recall improved, but the task itself is likely to be more resistant to stress. This concludes our lesson on information processing.